Welcome to RBD Instruments microCMA video, in which we'll describe our microCMA package in detail. The package includes the 2.75-inch CF flange-mounted cylindrical mirror analyzer, controller, software, Z-translator, and our 9103 USB picoammeter for measuring electron target current. Pierre Auger was a co-discoverer of the effect where X-ray stimulated atoms emit electrons with element-specific kinetic energies. In the 1960s, commercial Auger electron spectrometers were introduced, which used electron beams to stimulate the samples. All elements except for hydrogen and helium can be detected. It's a very surface-sensitive technique. It starts with the electron gun, which generates a 3 kV electron beam that hits the sample, target, and then electrons come off at all angles, but we accept only those at 42.3 degrees plus or minus 6 degrees. Those electrons are deflected by voltage that's applied to the outer cylinder, which forces the electrons down into a small aperture, which is in front of an electron multiplier, where the electrons get amplified and finally displayed as data. Here's a schematic that shows the electron gun, the target, the electrons being deflected through the aperture into the multiplier by the voltage that's applied on the sweep on the outer cylinder. Our CMA is very easy to operate. First, you position the end of the analyzer down close to the sample, about 4 millimeters away from the specimen. Turn the electron gun on at 2 kV. Set the target current to about 300 nanoamps. Acquire an elastic peak. Most of the electrons that hit the sample at 2 kV bounce off with that exact same energy, and so we can use that peak to position the sample. We move the analyzer in and out until we get it to cross over to exactly 2 kV, which is the focal point of the CMA, and also the peaks will be in the correct energies. Once you do the elastic peak, you can set your beam voltage to 3 kV, and again, about 300 nanoamps of target current is ideal. And we can acquire a wide scan, which generally is from 30 to 1030 EV, or you can acquire a multiplex, which is a series of narrow scans. And the advantage of the multiplex is that you can take multiple sweeps over. If you have a peak that's very, very small in the noise, you can take a lot of sweeps on that until you can pull that peak out of the noise. After you've got your data, you can smooth it, differentiate it. In the case of a survey, mark the peaks, and then do the atomic concentration calculation. All of the parts in the CMA can be replaced by the user in the field. The electron gun is a complete stack. It's pre-aligned. The electron multiplier is easy to replace. Why did we make it so small? So that it could fit on an existing chamber, because almost every chamber has a 2.75-inch lens that's available. Or if you're designing a new vacuum chamber, it can be much smaller, which helps keep the size of your pumps down. Signal to noise is comparable to much larger CMAs. A 10-inch shown here, and our 2.75-inch, the signal to noise is very, very comparable. Please contact us for more information at our website, www.rbdinstruments.com. Thank you.